So this is meant as a talk by me and Andrew Me, who cannot come to the conference in person, but he has sent over 2 videos that I'll show during the presentation. So this is me, Florian Bömers. I have my own software and hardware company specialized in MIDI translation, MIDI processing, and I'm also doing a lot of work in the MIDI Association for standardizing MIDI 2.0 standards, in particular network, MIDI 2 over networks, so that's a standard I'm working on right now. Andrew Me is also very active in the MIDI Association and creating prototyping tools, and we'll see some of his work during the presentation. Okay, a quick recap of MIDI 2.0. There's way too much to be handled in just a couple of minutes, so I'll just give you a few highlights. So MIDI 2.0 is not only a new protocol, what most people would expect, but it's also a large portion called MIDI-CI, which actually runs on MIDI 1.0. It uses system-exclusive messages, and it helps or enables discovery of other MIDI-CI devices. Then there's a section called Profiles, where it can enable and disable high-level functionality. And there's a section Property Exchange, which allows you to get and ask questions and get a reply with more fine-grained, detailed information about a device or an implementation. There's also a third area, protocol negotiation, or fourth, if you look at this right here, which is meant to switch from MIDI 1 protocol to MIDI 2 protocol. This is being deprecated soon, so I will not talk about it here. In UMP, that's the Universal MIDI Packet, that is the new MIDI 2 protocol. We have more channels. They're organized in 16 groups with 16 channels each. And the Universal MIDI Packet can transport either or both MIDI 1.0 protocol messages and MIDI 2.0 protocol messages. So just some quick things about MIDI-CI. The discovery message requires bidirectional MIDI, and that is actually the main new thing about MIDI-CI, that you cannot just send out MIDI and you're done. You first have to negotiate and discover who's out there. So basically, to enable MIDI-CI discovery in your implementation, just send a discovery message, wait for the reply, and if there's no reply, then you know there's no MIDI-CI device on the other end. If you get a reply, you know, okay, whoever I'm talking to is a MIDI-CI device. And there's also a so-called MUID, MIDI Universal Identifier, which allows multiple devices to be on the same MIDI transport. So you can distinguish multiple devices. So a deep look into the discovery message. It's all sysx. These are hexadecimal. This is a hexadecimal representation. It starts off with the MIDI-CI Universal System Exclusive header. The 7.0 is the sort of status code for discovery message, and we're having a version field. So this is 01, meaning MIDI-CI message version 1.1. The next section are the source MUID and the destination MUID. In this case, it's a special destination broadcast address 7F, 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 7F. And the next fields, you have a short description of your own device, manufacturer ID, device family, device model, and your device version. So whoever you're sending that discovery message knows already about your own, about who is sending that. Then you also tell the other device which MIDI-CI categories are supported. Protocol negotiation, profiles, property exchange are currently available, and the MIDI Association is working on more categories with adding more functionality to MIDI-CI. And you can also specify the maximum size of sysx messages that you support. So there are 4 bytes available for that. So that also helps interoperability. For small devices that don't have a large buffer, you have to break messages up so that they don't get too long. The next section of MIDI-CI is profiles. You can discover which profiles are supported by any device that you can reach via MIDI. And then you can say, can enable a profile and you can disable it. And a profile is high-level functionality. For example, general MIDI. So from the outside, you can query, hey, which profiles do you have? It tells you, I got general MIDI and MIDI show control. And so you can send the set profile on message so that the other device will now go into show control mode, for example. So you can really remote control a device via profiles and find out what it is capable of. Property exchange, as said, is more like a fine-grained get, set, and subscribe mechanism. It uses resources, and each resource has a number of properties. Every property is just a key value pair. So I'm going to skip over the fine print here. This is an example, a very important example, the device info resource. Every device should support this one if it supports property exchange at all. It's a very simple and very fast way to get some basic information about a device. And you can actually specify UTF-8 strings in here. So a much better way to describe your device than handing out sysx manufacturer IDs or something, and letting the other device guess what it is. And it's also useful to re-identify a device. You plug it in again, and then you get the device info resource, and you know, okay, I know that device now, can reconfigure it as I like it. For the UMP, Universal MIDI Packet, this is how it looks like. It's based on 32-bit words, and the messages are 1 to 4 words long. The shortest messages have just 1 word, and longer messages have 2, 3, or 4 words. And this is where all the new functionality is going in with respect to channel voice messages, higher resolution. We have 32-bit resolution for controller messages. There's per node controllers. So a lot of new functionality in UMP, and it's extensible. So in future, the MIDI Association will come out with more standards and more functionality for UMP. And of course, all MIDI 1.0 messages have an equivalent in UMP with high resolution, additional parameters, and it all operates on more channels. You have groups. UMP also has JR timestamps. They are standardized, and a device that advertises JR timestamp functionality can negotiate to start using JR timestamps, and then every every message is timestamped. I'll get some water. UMP is also backwards compatible because it uses the same concepts as MIDI. You can mix and match MIDI 1.0 and MIDI 2.2 devices. There's a defined set of translation rules. So UMP really is MIDI, just a little better, a little bit more of MIDI in every sense. One problem with UMP is that it's a new packet format, so you need new transports. USB MIDI 2.0, the standard is ratified in the USB-IF. And we see more and more operating system support. macOS was the first one. Android now has USB MIDI 2.0 support. And on Windows and Linux, we are expecting it, or announcements, relatively soon. And tomorrow there'll be a talk about operating system support. My voice. So UMP over network is a standard that is currently being worked on in the MIDI Association and hopefully soon ratified, because that's a very useful transport, high bandwidth, and a lot of devices can then connect to each other. So yes, the specifications are out there. You can download them from the MIDI Association website, MIDI.org. And the MIDI Association is very busy working on updates to the existing specifications. There are a couple of things that need to be sort of fine-tuned, and there'll be updates soon. And also new specifications are being worked on, new profiles, property exchange resources, and that will probably go on for quite some time. So that was the first section, a quick recap of what is MIDI 2.0. We're now looking at how to start development of MIDI 2.0. So in general, you shouldn't be afraid of anything. It doesn't mean that you need to rewrite all your MIDI code. You can go step by step and just use MIDI 2.0 functionality where it's actually useful. MIDI-CI doesn't even need a different packet format or a different transport. So it is usually quite quick to, for example, just implement MIDI-CI discovery, and all of a sudden a DAW can auto detect the presence of your device and what kind of device it is, or software, of course. And the same applies to UMP. You can, for example, switch to UMP internally and on the outside still use MIDI 1.0 or use MIDI 1.0 over UMP. So lots of ways to have a gradual transition to MIDI 2.0. The specifications are all available for free on the MIDI.org website. You just need a free MIDI.org account. And let's look at some details of actual implementation. So if profiles, as said, is more like a enabling and disabling high-level functionality, and that might apply to your product. So you can consider exposing that as a profile and making it auto-discoverable, and DAWs, once they have full MIDI-CI support, can then sort of much better display the functionality of your device without the knowledge, without any previous knowledge about your device. It can just query which profiles are there. And the same applies to property exchange. Device info is very useful. It's not so hard to implement property exchange, and we'll see a little later for some existing code. Property exchange also allows you to expose a list of your available channels, and what is in which channel, a program list, if you have different programs, controllers and controller names. So these are little things that go a long way for auto configuration and user experience. Now, profiles and PE, property exchange resources, are standardized by the MIDI Association, but there is also a way to define or to use manufacturer-specific profiles and resources. They are prefixed with an X dash in the name, and then you can define your own resources, and profiles also have a section for manufacturer-specific profiles. So in principle, when there's a profile missing, you can just invent your own, document what it does, and be done. Or if you think it's a generally useful profile, you can consider joining the MIDI Association and start working on standardizing it. It's a relatively easy process for a profile because there's not much actual, it's more text than code. Okay, let's see. MIDI-CI protocol negotiation is used to switch from MIDI 1.0 to MIDI 2.0 protocol, but that is actually happening on UMP layer. So the MIDI Association found that it's kind of strange to have that switch in MIDI-CI, and MIDI-CI is on MIDI 1.0 transport. So it was kind of strange. So it will be deprecated, and then the protocol switching can be done inside UMP, where it makes sense. Because UMP has MIDI 1.0 and MIDI 2.0 protocol, and you usually start off in MIDI 1.0 mode, and then you say, okay, now I want to switch to MIDI 2.0 protocol, and that both sides agree to use MIDI 2.0 protocol. All right. So for UMP development, the main problem right now is how to interface with other applications, with UMP devices. Are there any UMP devices? How can I test? How does it work? I need an OS API. I need some kind of transport. So on macOS and iOS, iPadOS, it is actually quite nice because they have put a lot of effort into switching the entire core MIDI to UMP. And so you can still use the old API for MIDI byte streams using MIDI packet list, but you're encouraged to use MIDI event list, which is based on UMP, and it works on all current versions of macOS, iOS, and iPadOS. And again, there you can switch to UMP, but still use MIDI 1.0 protocol, and macOS will do the translation necessary if you are talking to a MIDI 2 device, for example. So it's quite convenient. So in general, I would say if you're developing a new application, go with UMP from the beginning. And if you want, you can still use MIDI 1.0 protocol. You can also use MIDI 2.0 protocol, and Core MIDI will take care of everything. Core MIDI has also MIDI-CI functionality, but I don't know. I haven't tested it myself, so I don't know how well or how useful that is, because you can also implement your own MIDI-CI functionality in your own code. This is the core function to use if you want to go with the MIDI 2.0 protocol on Apple. This is a relatively new function in Core MIDI, and you see the line K MIDI protocol _2_0. That is to select MIDI 2 protocol. And using that, you can already start using high-resolution controllers, high-resolution note messages. And so that is mostly it, because all other functions for Core MIDI are either the same or have the same structure as previous byte-based Core MIDI functions. Now on Android, we have MIDI available for a long time, and also native MIDI support since API level 29. And UMP is available since API level 33. It is implemented on a different layer, so you can open, and I show it here. How you do it is you open a device in UMP mode, and if that succeeds, then you're working on UMP, and if that doesn't work, if it's not a UMP device, you will have to open it in MIDI 1.0 mode. And all other MIDI functionality in Android is the same as with MIDI 1.0 because it's using byte buffers. So you have to know if it's UMP coming in or a MIDI byte stream. Okay. On Windows, we don't have an API yet. And there was recently an announcement that Arminode, a company, is implementing an open source driver for Windows, which with the hope or the plan that is then integrated into Windows. So we have a USB driver available on Windows too, and Microsoft is also working on an API. Tomorrow there will be a session at 9 a.m. where representatives of Microsoft, Google, and Apple will explain a little better and in more detail what their plans are. On Linux, as it is open source, you cannot. It's a different way to get things into the kernel, and ALSA is the main area of the Linux kernel handling MIDI. So in the MIDI Association, we have contacted the main ALSA developers for MIDI, and hopefully that will be fruitful for a MIDI 2 driver soon. So as long as you're implementing or want to start MIDI 2 development and there's no OS API available, what can you do? You can still start using UMP inside your application. And on Mac, you can just then hook into the UMP APIs of the operating system, or on Android. If you're on Windows, you can have like a thin translation layer whenever you're interfacing with actual hardware or other devices, MIDI ports, and translate that to MIDI 1.0. And for existing applications, it's also a good idea to at least start planning for converting it to UMP if you want to benefit of the new functionality and all the great stuff. And then there is also Juice, which announced MIDI 2.0 support a while ago, but unfortunately it hasn't shipped yet with a complete MIDI 2 implementation. It's also somewhat difficult because it wouldn't work on Windows. So there is some preliminary UMP API and implementation available in Juice, but it's sort of unofficial. You can see it in the workspace, but it's not open, and there's no device I/O. Okay, and of course it would be great to have existing code, and I thought I should open source what I created for a workshop, and I did that yesterday. So this is brand new code that you can explore. There are a bunch of classes from MIDI-CI Profiles and Property Exchange, and there's a Juice demo project where you can see all messages going in and out and enable, disable profiles. And pretty much the same for UMP. There's a UMP sender and the UMP receiver application, which might help you develop your own UMP application, or you look at the code, how to open a macOS UMP device and how to interface with that. It also comes with utility classes for UMP, so might give you a jump start for UMP development. All that is published under MIT, so free for everyone, basically. In the MIDI Association, we also have a closed private repository space where we share code. So for MIDI Association members, there are some more options to exchange code, to discuss, and to start development. And let's see. Yes, and there are also online courses. As said, those workshops are the ones that I use for creating that those libraries that are on GitHub now, and they are still available as on-demand courses. So if you want to know what that code does, you can see it there. Okay, the next area is how to debug your MIDI 2.0 code. And as said, that can be kind of difficult if you don't have any MIDI 2.0 devices or any MIDI 2.0 software that you can test it with. So inside the MIDI Association, we use a tool called the Workbench, which is created by Andrew, and he sent us a video, which I will show now.
The MIDI Workbench is a free tool for MIDI Association members to help developers develop, debug, and deploy MIDI 2 application and devices. It runs on Windows, Mac, and Linux. The Workbench connects to your device or software to test various MIDI 2 implementation features against the currently released specifications. The Workbench starts with a very simple page that shows MIDI 1 data format devices using MIDI-CI and MIDI 2 devices using the universal MIDI packet format. Let's start with the groove sizer TB2 in the first column. The TB2 has been programmed to use MIDI-CI. This code is also available to MIDI Association members for experimenting with running MIDI-CI on low-end embedded platforms. By opening up the debug window, we can see the sysx messages that are exchanged between the Workbench and TB2. We can delve into the sysx to see the details of the data by hovering over each field. Let's continue to investigate the TB2 further. Using MIDI-CI, the Workbench performs discovery to find out as much information about the TB2. Again, we can see in the debug window the TB2 also handles property exchange. Oh, and what's that? Errors. The Workbench provides in-depth warnings and error checking to help debug the device. Once in, you are then presented with a series of questions and tests your device should consider, as well as a series of screens that help test each of the P's. In this case, here is property exchange. And you can even see that it tests subscribed resources. The Workbench aims to remove significant hurdles to MIDI 2 development.
Oh, and we have a live demo. Do we have enough time? Yes. So there are two tools called the Bome MIDI-CI Initiator and the Responder. So what they do is one is acting as a device that queries other devices out there and finds out all information about it. And the other simulates being a device or a software that exposes MIDI-CI information. So this is the initiator, And let's also start the responder. So the responder, first of all, you define a virtual MIDI port that it's responding on. And you can see there are these three well-known sections: device discovery. So we can enter here all the information for the discovery. There are profiles that you can set up on your own. Just give it a name and a profile ID. So it should start with your manufacturer ID and then have just a random number that you can define. And we can say this profile works on channels 3, 5, and 8. And now we have that profile. For property exchange, there's already a device info resource pre-filled, and we could add more in JSON format, but right now, let's keep it as that. And now let's have the initiator query all that information. So we select the MIDI port, and now it does the discovery, and you can see here in the log window, there's a lot of messages going back and forth. And it discovered all the information from the device discovery. It discovered that profile on these three channels, and it found the device info. Now, profiles, as said, you can enable and disable them. So if I click here on channel 3, it'll send the message to enable that profile on channel 3, and that's also what is displayed here. And this also works the other way around. If the device says, hey, I've just, or the user enabled channel 5, that profile on channel 5 on the device itself, it'll send it back as a report to the DAW, and then it can display it there. So yes, this is a quick demo of these tools. They will be available soon, maybe today, on my website. And I'll give you a link at the end. Let's see. I think that's good for now. Another tool that we use in the MIDI Association is a hardware product. And we have one here. And a video to go with that, again, from Andrew.
Hi again. This is the Note Protozoa. It is a development board used to provide MIDI 2 testing. It has 2 USB ports, MIDI DIN in and out ports, 2 pots, 1 encoder, 7 capacitive buttons, optional display, and 2 customizable expansion ports. Generally, the UUT board is set up as a MIDI to USB device, while the main USB is set up for inline debugging. The expansion port currently accepts CME WIDI core modules for Bluetooth support, with more modules like Ethernet currently under development. As the code is available to MIDI Association members, it can be configured in any way you need, including testing USB MIDI 2 configuration, including different group terminal block configurations, UMP echo, sending UMP data for testing, MIDI 1 data format translation, MIDI-CI testing, UMP transport to USB testing, and other options, of course. Here, the Protozoa is connected to the workbench running as a USB MIDI 2 device. As this is a UMP device, we can review the UMP information and verify the Protozoa is set up correctly. We can see here that the Protozoa is set up, and now from the Protozoa we can send UMP test messages to the workbench. We can also debug the incoming UMP messages to the Protozoa within an IDE that supports OpenOCD. Using the workbench, let's send through some UMP data and step through the processing of that data. As we see here, we have a handle note on function which shows the receive note coming up through here. We can also step through So for example, I put a breakpoint there and then send through a note. We've now hit here and we can now step through this debugging as you would normally do so. Protozoa's source code is provided under a license for MIDI Association members to use it in their own commercial products, including the USB MIDI 2 device functionality. MIDI Association members are currently using the Workbench and Protozoa to test new MIDI 2 features which will be published in future specifications, such as endpoint discovery with protocol selection and function blocks.
So just a quick slide of other tools that we use. The Groove Sizer TB2 is a Arduino Due-based synthesizer, and we use it internally also for development and to see how MIDI 2 works on very small devices. Then there's my product called the Bome Box. It ships with some MIDI-CI functionality since firmware 1.5, released in May of this year. Basically, device discovery and some property exchange for discovering some features. And it can be updated with new firmware versions. So I'm planning to add UMP support and more MIDI-CI functionality with firmware updates. So for deploying MIDI 2.0 products, there is really two very important things to consider. One, the MIDI 2.0 name really requires that you support MIDI-CI discovery and at least one of these three Ps, profiles, property exchange, or protocol negotiation. So that shouldn't be too hard, but you shouldn't call it a MIDI 2.0 device if you don't do any of that. And then there is also a logo program. So to use that new MIDI logo on your product, you need to have a license with the MIDI Association. It involves self-certification, and then you send the results of that certification to the MIDI Association and sign a license agreement, and then you can use that logo. More and more companies are licensing it, and it also, makes your device distinct, and people know, okay, this device has some MIDI 2.0 functionality.
I'm Mike Kent from Ominote. My company makes the Protozoa that Andrew was just showing you, the test board, and I'm the chair of the MIDI 2 working group in the MIDI Association. I'd like to talk to you about membership in the MIDI Association. There's two levels of membership. You can go to MIDI.org and sign up for free, and that allows you to download all the specifications. So you can find the core MIDI 2 specifications there, and then all kinds of extensions, profiles, property exchange, all of that kind of thing is there. I think there's a total now of about 13 or 15 specs already there that you can get for free just by signing up for that free membership. But you might want to consider the paid membership, and I'll just give you a few pointers as to why. First of all, you get early access to specifications when they're in development. And you can indeed have input or influence over those specifications. It's a great time-to-market benefit in participating in that way. It gives you a SysX ID. You do need a SysX ID really to do MIDI 2.0. It's how we do all these bidirectional API-like things with MIDI 2.0. So your device is identified by a SysX ID. So you need to get one of those anyway. It gives you access to the software and hardware tools. All the things that Florian and Andrew have been showing here today, those tools are all available to members. And in the future, if you just choose not to join at this time, at this level, Those things will be available open source. The MIDI Association has adopted a policy of open source, and we want to provide these tools and libraries as we're able to develop them. Of course, all of this is done by members, so they're volunteering. So any source code and libraries that we release is because somebody has volunteered to give them. But there's great value there, and if you want access to those now, then please join. You can also license the new MIDI logo at no charge. And so that's one way that we're going to be promoting MIDI 2.0 to the marketplace is the use of the logo. We will list your products on MIDI.org, both in articles about your new products. We have a huge user base there and a mailing list of customers. Your customers are coming to .midi.org if you're making MIDI products. And so it's a great way just to get exposure to your customers and potential new customers. And we're actually going to be setting up a database where you can go in and enter your products and enter in the MIDI 2 features that you've supported. So it'll be a searchable database. Show me all of the MIDI products that implement, for example, property exchange, or all of the ones that conform to the orchestral articulation profile. And so we're putting together that database functionality where you can put your products. It costs $600 to join for most small developers. That's what my company pays. It gives me the same voting power as Microsoft, Google, and Apple, who all pay the top price at $20,000. And so you can join at MIDI.org and contribute and get something back out of it. And if you want to know more about that, come and see us downstairs. We've got a little display set up downstairs. I'll be hanging out there. JB will be there a lot of the time. Florian's hanging around too. Just look for any one of the three of us good-looking guys down there. Thanks.
Thanks, Mike. Yeah, and there's some fun people in the MIDI Association, most of them. So what's next? Immediately, for the immediate future, tomorrow morning, as hinted, at 9 a.m., there's the talk about operating system support by actual representatives of those three major operating systems. And then also, as already said, there will be new versions of MIDI-CI, of the core MIDI-CI and UMP specifications soon. We don't know exactly when. It has to go through the voting process and everything in the MIDI Association, but there will be new versions and with some significant, small but significant changes. And that is pretty much everything I wanted to tell you today. So I open up the floor to questions.